Hello, my name is Mark Elliott. I am the Chief Operating Officer of Europa Science, which is the publisher of Imaging and Machine Vision Europe. Thank you for joining us today. We have an interesting panel discussion on the topic of AI, which is obviously one of those technologies that seemed to be science fiction a few years ago, but has now very much become part of our day-to-day lives. And this discussion topic is around setting the expectations of that. We're all using it in our day-to-day lives, particularly in this industry. But we want to understand kind of where it's going and what it can do now and where those boundaries exist on a practical level. I'm very pleased to say we've got four great people joining us today to discuss this with us. We have Jan Naessens, who is a Vision Sales Account Manager for Zebra. We have Matthias Kirschgall, who is the CTIO and owner of EVK. We have Bruno Menard, who is the Director of Software and Program Manager at Teledyne DALSA. And David Johnson joins us as well. He is the Chief Engineer at Lockheed Martin UK Ampthill. So welcome to you all. The basic format for everybody today is reasonably straightforward. I'm going to hand over to our presenters to sort of give themselves a bit of introduction time. And then we're going to go straight into our first topic area, which is about technology limitations. And Bruno's going to kick that off with a slide deck, which will start the discussion. And then I will go to everybody to input as we go through the debate. If you watching wherever you're watching, at home, at the office, etc., want to ask a question, you can field that to us at any point, and I'll try to do my best to come back to those questions. Obviously, David, welcome from Lockheed Martin UK. Really pleased to have you with us. Jan, do you want to talk us through who you are and a little bit about Zebra, please? Thank you.
So, good afternoon, everybody. My name is Jan Naessens. I joined Zebra recently, early this year. I have a background in automation and machine vision. Spent quite some time at Cognex and now joined, let's say, the herd of Zebra in March of this year. Just a little bit of an introduction. If you look at Zebra, established company, for a couple of decades with significant global sales, almost 5 billion. We have global offices worldwide, almost 10,000 people are working for us. And I think one of the key features is also that we have over 10,000 channel partners. So if you then look at a little bit what drives let's say the business and what drives Zebra to invest in AI, machine vision, and fixed industrial scanning is just a market. What we see is more and more automation. More and more automation means for Zebra less and less wearables and less and less people running around in a warehouse. More machines are being deployed, but still we need to scan. Still, we have to check. So hence. The decision of Zebra to step into the world of AI and machine vision. So if you look at our investments, actually look at our retail products. It's already let's say been used in the more common products. Apologies. If you look at in retail, if you look at our handheld devices, there's some computer vision already and AI being used. And then on the other side, machine vision. The fixed scanners, the machine vision products that are being used currently have the AI tools already in it. This is basically a result of own development. The FS series is an own development of Zebra, but we also did some acquisitions in the last couple of years. Matrox Imaging from Canada was one, and then the other one 3 years ago, Adaptive Vision. Polish company who is specialized in deep learning and OCR.
Okay.
So the last slide here. I think the benefits of what we bring to market is our combined solution where we have software but also hardware. We're talking about easy to be implement sensors, fixed scanners, to read barcodes, all the way to AI-based machine vision systems to do anomaly detection, to do 3D vision. So we have basically a full suite of products and software to solve those problems. That's it from my side.
Thank you very much, Jan. That's good to get that overview. And Matthias, tell us a little bit about you and EVK, please.
Yeah, thanks. My name is Matthias Kerschagel, and I'm here for EVK. EVK is a small expert company located in Austria near the city of Graz. And I sort of grew up with EVK, so we are out there since more than 35 years. And we have specialized in the market of sensor-based sorting and control, where we are a key supplier for sensors as well as software and data analysis tools for, let's say, a very fast sensor data streams coming from a production line. And our core IP lies with hyperspectral imaging in the near-infrared regime that can be used for waste management as well as food sorting and also mining and so forth. Also, another technology would be conductivity imaging, which is basically metal scanning. And this technology we are using in all sorts of production facilities where you either want to remove foreign material from a good product, or where you want to infer quantitative information from your products in terms of quality monitoring or so. And yeah, and that is also the reason why we started to invest and to develop artificial intelligence, deep learning for our data analysis tools, because the sensors of today are quite evolved, and I think the recent advancements in the last 2 or 3 decades in sensor hardware technology are quite evolved, but what is not so well evolved is the usage of the data we have at hand. And in order to harness the data we see, particularly high-dimensional data like hyperspectral imaging data, artificial intelligence, and most of all deep learning seems to be very promising, and it's very useful to get out the best key data of the sensor data you have. And yeah, that's the reason why we are doing what we are doing. And our customers are, for the most part, machine builders who build sorting machines or monitoring machines, and who would integrate our offerings into their machinery. And we like to give a sort of a sensory turnkey solution to them, so that they do not have to take care about the guts of a sensor system and all the complicated algorithms and the configuration. So that's what we like to do. And yeah, this is about it. Thanks for having me here.
No, very welcome to have you. Thank you. Right, Bruno, we're going to come to you next. You're going to tell us a little bit about Teledyne, and then we're going to go straight into the first topic area, which is around technology limitations. Basically, where are the boundaries at the moment, and what do vendors need to work against, and what should they be pushing at? So, Bruno, over to you, and then we'll go on to your slide to talk about that topic, and then we'll open up the debate more widely. Thanks.
All right, thank you, Mark. I'm Bruno Menard. I'm a software director at Teledyne DALSA, the imaging division of Teledyne. So just to talk about Teledyne, it's a huge company with more than 15,000 employees in the world. We're typically in the sensing world where measurements are taking place. My division is focused on imaging products with different sensing and wavelength, from X-ray imagers to infrared, like from shortwave to long wave, visible cameras, frame grabbers to link the high-end cameras to the PC, and smart cameras, and finally software. And today we're talking about AI. Our industry is like it's very broad, so it's from electronics to food, pharmaceutical, logistic, transport, automotive, and just to name a few. And we have focused our energy on development of AI in the last, I would say, 7 to 8 years, and reaching out to customers who wants to integrate AI in their industry for mainly inspection of parts, like wafer inspection, like PCB inspection. In my slide on the lower corner, left corner, I mentioned like a few example of, for example, the LED inspection, where they need to find like the position and the angle of the LEDs to inspect them and make sure they're well soldered and they're well positions. Beer can inspection for finding the dents in the type of beer bottles. These are example. Sorting plastic in the plastic sorting industry with a high degree of regulations. These are a couple of examples that we have gone through recently. Maybe we want to talk about the technology limitation right now.
Please, yes. Talk us through some thoughts. So, you've obviously been working on this for a long time. You've been developing these algorithms. What sort of boundaries have you come up across? And are there any trends emerging about how to deal with this? Yeah,
of course. So there are many like barriers to adopting AI from a technology point of view, from a user point of view. We have identified, I've identified like 3 of them. The first one being we are producing high resolution sensor. We're a victim of our old technology because, in fact, when you generate a lot of data, you need to be able to process all this data. And if you think about AI, you think about the neural network where each of the input layers will be connected to each pixel. So if you have, like, for example, a 4K by 4K area sensor, you end up having to connect 16 million neurons to the input. So in practice, it's just not doable, even with great GPUs. So we propose different techniques, like, for example, we condition the image by shrinking down the image to a certain size, let's say 1K by 1K. But this has drawbacks because people, if they want to choose like a high resolution sensor, that means that they want to inspect a large field of view while keeping all these details. For instance, on a wafer inspection application, they want to find like little dust and the shape of the defect. They will find that they will be able to find the scratches of little tiny defects that appear in the field of view. So they want to keep the native resolution as much as possible and being able to process all this data with AI. So we are suggesting like the vendor should be able to provide a technique called tiling, which typically splits the image into little crops and feed these cropping images one by one to the neural network and recombine it all into one single consistent result. That's a technique that we've been promoting to be able to deal with large amount of data for AI. And of course, you end up with something that you need to accelerate. And the acceleration needs like the batching and parallelism as much as possible. Good GPUs are required at the runtime or also at the training time. A second boundary that we have identified is that many of our customers are in the same industry and they want to deploy a system with hardware and robots and everything they need to inspect some parts on their production line. And maybe they want to stay for 5 to 10 years with the same hardware system. But at some point, they would like to introduce AI, but they want to keep the system the same. So they want typically the system to be upgraded on a software basis only, which means that our AI needs to run on the old CPU, which is not typically good enough for providing acceleration. So typically, we as vendors, what we need to do is to be able to offer acceleration on CPU to be able to allow each of these end users to upgrade their system. Eventually, this will disappear because all these machines will be replaced by proper hardware with GPUs and, for example, a smart camera with a neural core. But for the time being, it's still a hurdle that we have seen, and we have been able to find ways to accelerate the neural networks, as today we're capable of providing a really decent inference speed on CPUs. And the last one, everyone has heard about it, is the data drift on the production line. So once you've deployed a model, it comes as a black box. And this black box, you want to have the ability to retrain it or adapt it with a little amount of effort so that it keeps doing well on the new types of defects. For example, if the defects were a certain shape, but some of the defects never trained on it because you did not have enough data to train on. So we have imagined like two main categories of solution for that. The first is called continual learning, which is our typical specialized algorithms where the tail or the head of the neural network is transformed so that it can adapt itself by providing a few samples, extra sample with annotations at the production level. So that means you don't need the big system you've used for AI in the lab or AI training. You can have an operator which has no knowledge of AI at all and provide these extra samples to retrain the model, which is still a black box, but it adapts itself to the new types of defect. Let's say the defect shape or texture has changed a little bit. And the last solution is to use algorithms which are inherently capable of dealing with changes. And we have identified like anomaly detection, which probably a lot of people have heard about it. Anomaly detection is a binary classifier which is trained to detect, to differentiate the good and bad parts, but is typically trained on good samples only, so that by a threshold on anomaly level, it's capable of extrapolating anything which is considered an anomaly. So that means that once the black box is deployed on the field, it can detect any type of defects that it's never been seen at the training level. It's a sort of prevention from being vulnerable to any change and back to the data drift, to be less vulnerable to the data drift on the production line. Yeah, that's pretty much the three big categories or boundaries that we identify in our market.
Okay, thank you, Bruno. So I was going to come to David actually next. I mean, obviously Bruno's identified three there. Broadly comparable experience from your perspective?
Yes, I think from a technical perspective, I would say broadly comparable experience. I would echo things like the computational resources, the compute power is really an issue. But perhaps from a defense perspective, there are a couple of other slightly more abstract technical limitations that I come across. So first of all, data privacy, data security, and the regulatory environment in defense is often different from that used in other industrial fields. So that can be a real challenge for us. It means that navigating the approvals that we require in order to design and implement artificial intelligence enabled vision systems can be quite a lengthy and costly process. So really the technology limitation there is the clarity of the pedigree of the foundation models that we might be using, assuming that we're not developing our own model. And I'll put development of our own models to one side for the moment. So really, I think that would be really advantageous if developers could focus on it is making sure that foundation models do have clear pedigree, do have clear documentation and understanding and performance characterization going with them, so that as we start to develop them for application, the lack of that documentation doesn't become a technical limitation within the defense environment, because it can be a really challenging aspect if we're seeking to use independently developed models that we've got limited information on, and really drives verification and validation burdens, which lengthens defense timescales. And in a fast-paced environment like AI and machine learning, the time, by the time you approve something, it could be outdated. Secondly, I think one of the topics that was just mentioned there is the quality of the data that you have to either train or apply reinforcement learning onto the model. So having good quality data is really challenging, particularly when you're dealing with vision systems in a defense environment, because often it's very hard to represent the visuals that would be in a real combat or real defense environment. Even if you've got relatively realistic real world training, the visuals are quite limited, quite challenging. So that really does become a technical limitation. So really novel approaches are required in order for us to mix synthetic data with real data to get the levels of accuracy in our models that use vision systems in order to be able to prove them and qualify them for defense applications. So I think those would be the key points I would make in terms of technical limitations at this point in time.
Okay, thank you. And Matthias, any views from your side of the fence?
Yeah, sure. I would agree with what has been having said already, but I would add to the story that in our markets and in our applications, the biggest drawback is, or the biggest advantage of AI, and I mean particularly deep learning, is also the biggest drawback, because deep learning at the end of the day is an automized way of feature extraction, something that an expert or an engineer did in the old days, and which facilitates modeling and predictive models now quite easily. But it also makes the system error prone, because domain knowledge becomes more important now. You have to understand your data better, and particularly if you're working in a changing and environment like in the industrial, in the production lines where you have humidity and vibrations and everything. Such extraction of features which are not causal, right, and which might infer correlations, but they're not physically and causal, might introduce errors. And that's, I think, one of the biggest drawbacks. Having said that, or along the same lines, it's also people are used from the past that they can interpret the results and that they can manipulate at different stages of the data analysis process. This we have lost as well, because if you train a backbone, a neural network, you train it as one entity. It's difficult to say what really happens in one of the deep layers. Maybe in the first layers you see, okay, I see some edges, or I see some features or shapes that I recognize as a human. But deeper down, it becomes literally impossible. And people like their little slider bars, right, where they can tune their models with more or less, or introduce thresholds. And all this is not possible as such any longer. And that's something that the customer, I think, is missing dearly. And where also research is done, like interpretable AI, and where there's still work to be done in order to, let's say, have the good things from both worlds, from the promise of AI, which is inference of features in an optimized way, plus the ability for humans to interfere and to add their domain knowledge, not only by means of choosing the right data sets. Yeah.
Okay, thank you. And yeah, and from your perspective, are customers coming into this with their eyes open? When people approach you about a solution, do they understand the challenges that lie ahead, and how do you help them overcome those challenges during, I'm guessing, the iterative discussions that then take place?
Yes. So
I mean,
what Matthias said.
Sorry.
Yeah, no.
What Matthias says, and I kind of can relate to that a little bit. So one of the things I notice when people come, some people come to me and ask about a certain solution. It's a little bit like machine vision was 25 years ago, where they thought this is a technology is going to solve every little problem. Everything that couldn't be done can be done now with this new technology. It's sometimes they forget it's artificial intelligence, but you have to tell the system what to look for. So you still have to train the model. It's still people saying, okay, this is how it looks like. This is good. This is bad. That's one thing. And then the other thing is that also they forget that it's still, especially then with machine vision, they think that it's going to replace a human being. So the fact that a human being can actually look at the product and turn it around with cameras, you're still using fixed cameras. So it means that, okay, you can do 3D, but still, I mean, sometimes you look at an object, you turn it 360 degrees and it looks completely different. What I always tell people to understand AI and deep learning machine vision systems is, have you tried to unlock your phone by showing the back of your head? It doesn't work. You still have to look, you have to show your face. And then it kind of dawned to them that, okay, it's still not let's say a technology that is going to solve all their problems, let's say. So it requires some education.
And is there a general kind of number one pitfall? And this is a quick question to everybody. Is there a number one pitfall that, in your experience, when you're starting out on these projects, that people routinely fall into? And I'm going to go back to Bruno, if you don't mind.
Yeah. Thank you, Mark. I think like the lack of data and the lack of what I could say labeled data is probably the primary challenge that we're seeing in my domain. So like people are not ready to jump into AI just because they haven't collected enough data. So what I start to tell customers is, start collecting data in your current system, which will be able to feed the next generation system. A lot of these industries, they will be inspecting the same thing in 5 years, but with a different technology. So why not starting to collect the data right now, even if it's not intuitive, but it will help a lot reduce the amount of time you spend on collecting data. And of course, like I've seen like people like sending me images for using AI and ask me to make a prototype, and they've taken a few images with their cell phone, like 5 to 10 images or something like that. I think AI is going towards like algorithm like we can call few shot imaging, where you can like run a model with a few tens of images. Today, we're still expecting like they'll be collecting something like a few hundreds of images to be able to deploy something. And our goals, I think, as vendors, is to provide them with a good environment to collect the images and to provide the good tool to augment. There are techniques like image augmentation, which you can start from a certain number of images. With permutation, you can augment this. And today, with generative AI, we're capable of doing more. Like we can be able to blend artificial images with natural images that they've collected themselves and make a really good data set. And at the end, some people will have a lot of images collected, but they're not described, they're not annotated or labeled, as we can say. And we need also to provide good tools to help them annotate quickly by introducing tools like auto labeling. For example, you've trained a model which is not accurate enough, but it can generate some new labels for you to help you speed up the pace of annotating and come up with the data set, which is pretty good. I come back to David's comment on having quality data. I think the quality data is to have enough, and this data needs to represent the reality. So something that will look like the images that you'll be collecting when you deploy on the field.
Okay, so get your data sorted. That's the number one takeaway for that. Matthias, anything to add to that?
I would say the biggest pitfall is to advance too quickly or too swiftly from internal validation to external validation, or a lack of validation altogether. So people get excited and they see first really good results, but I always say be careful, because maybe you haven't covered the whole phase space, particularly in a production line where things can change, and you never can be sure that your feature is stable with respect to a 24/7 production. So better do test runs again and again and again. And maybe there's this one incident that happens once a month you captured with training data, but it will vanish the other day, and all your results are biased. And yeah, that would be for me the biggest pitfall for beginners. Yeah.
So, David, I'm thinking that a lot of your contexts are pretty hard to kind of, predict, right? There's not a hugely consistent sort of, use case or scenario setting. How do you manage that kind of volatility in terms of trying to get the preparation correct?
So I think it really is around upfront analysis and thought process on what exactly is it that we are trying to solve here. And I think it was just said then, you can't just try and solve the entire problem all in one go. Some of these technologies are very advanced and do offer amazing potential, but if you try and deploy them straight away, you can often be very disappointed about the results when you deploy them at scale. So for me, what we try and do is focus down on breaking the problem down, thinking about it in different stages, and then really going, okay, today we can with confidence solve this part of the problem. So really is about breaking it into those blocks. So just a normal engineering process. I think, however, just echoing the comment that's been said a couple of times, these systems require training, just like people require training. And the number one problem is the quality of the training that you apply to those systems. So it's the same as anybody doing a job. If you haven't been trained properly, you probably can't do the job. And if we don't apply good quality training with good quality data and then good quality testing to evaluate has the training stuck, that is the way that AI fails and machine learning systems fail. So we have to really think about them in that context. And you can't give your new employee who's just joined the company the job to run the whole production line, for example. You might give them a small part of it. So I think of AI a bit like that. I try and draw a simile and work out what it is that I'm going to do and break down the problem and then test it and then grow that employee or that AI system so it can do more of the problem space for me, and think of it as a tool. It's not there to replace people. It is there to augment people, particularly in defence. The objective isn't to or certainly for the UK and NATO, it isn't to replace people. It is human-machine teaming and augmentation to allow us to do our job better.
Okay. And then, Jan, in terms of sort of some of the issues you're facing where you're having to take systems into organizations, as David says, it's all about the people, right? And it's all about the training. Where do people go wrong with this? Do they not allow enough time? Do they not understand the skill sets that are required in terms of this? And how can a company like Zebra or anybody else that's represented here help that process routinely?
I think one of the issues I see from the start is when you start talking about AI, you start talking about the technology, you look at images and you look at possibilities. And one of the challenges is also sometimes to translate it into a working solution in their factory automation. I'll give you an example. People, let's say they want to look at a let's say wood inspection, which is brilliant for AI, and you can do amazing things. But then you take that application and they want to use it outside, in either in sunlight or in pitch black darkness, in summer, when the snow is falling, and which makes it a lot difficult. Or you want to have let's say a high-end system with a high-end PC with You want to take that into a deep freezer, for instance, that comes with certain challenges. So you have to, from the start, you have to explain the technology, what can the technology do, but then you also have to look at how are we going to implement that into your production environment, which sometimes is changing the complete opportunity. It's changing the complete project.
Okay. So, I mean, I'm guessing from what you're saying there, companies have to be incredibly flexible as they kind of work through this to understand where the direction of the work is going to go and how they resource around that. How often when you take on a project do you know where it's going to end up and what those kind of deviations are going to be like?
So it's basically what, so you talk about, first of all, people come with their samples or are coming with their problem, and then things become clear when you go on site. So one of the things I always try to do as quick as possible is to go on site, because in many occasions I found myself with the customer saying, what you need is not just a AI machine vision system, you need a complete machine, because it will require some handling, it requires I don't know what. So so it's basically being straightforward and consult the customer from the beginning, that this is going to require a little bit more than just an AI machine vision system. Okay.
And then, David, would you agree with that? I think we might have lost Matthias, actually. I'm not sure if he's still there. But, David, what's your take on that?
Yeah, I think in my experience, we often have two models of how we deploy these kinds of systems in defence. So one is a classical waterfall project management, and the customer will obviously have a very fixed vision in mind about what the outcome is going to look like, and we will end up spending a lot of time understanding how we're going to get there and planning that. So in those cases, we do all those things that we just talked about, but we're very upfront. We have detailed plans, and then we go forward. Where we're now moving to, though, is a bit more of an agile approach, as in, software development, agile. So often more outcome based, and we end up with quite a lot of flexibility as we go through the system development. So the customer will often have a lot of smaller hurdles that they want us to get over. And as we get over those, that gives us the opportunity then to fine tune how we're going to help them and resolve their bigger problem. And often, I think the problem we end up solving isn't what they imagined we'd solve at the start, but they're quite often happy with the outcome. So it can be an interesting journey. Part of that is probably because they don't always understand the capabilities of these technologies. So it probably is one of the challenges around deploying artificial intelligence, machine learning with vision systems is, well, what exactly is the capability? What can we do with this? How can it deliver benefits? Is not well understood in our customer community, and also it changes. It changes almost every day. I see a new announcement and a new advance, so that does affect what the customer then imagines they can achieve.
Yeah. And Matthias, just thinking about kind of, in terms of the people side of this and the scoping out and the project journey that you're on, is there always an early advocate, an obvious advocate in a project? And is that person a particular type of role typically? Or how do you go about finding the people that can make this happen on the ground?
Yeah, I think you need a very distinct and well-defined skill set to convey such projects. And I want to stress that deep learning AI, it's just another tool, right? And the tool itself will not solve anything. So in our applications, the same holds true that was true 20 years ago. It is, you need a lot of domain knowledge in order to use this tool properly and in order to solve an engineer problem or an application. So you all know the site garbage in, garbage out. If I give the tool to you and you do not know how to use it properly, you will not be successful. And I think, probably I'm biased here. I have a background as a physicist, but I think as a first approach, people who have some skills in different engineering areas, at least in my reckoning, quite suitable to convey such projects using this new tool, not forgetting about the other ingredients for a successful project.
Thank you. Thank you. And in terms of thinking ahead, you know, where does this go? Are there any particular long-term areas that we're focusing on where AI is making big advances and we see it making a lot more, or are there natural kind of endpoints to where this technology is going? Bruno, I'll start with you, if I may.
Okay, thank you. I think we hear about generative AI everywhere. And I think it will soon join the imaging world, at least in my world, to be able to use these kind of generative AI algorithms to generate more data. Like I mentioned before, like the lack of data is probably the biggest hurdle, what I've seen. And also what we can see is that maybe we can describe the whole system as to inspect a part on a production line. You have the camera, you have the acquisition, and then you have some portions which are responsible for processing the image with or without AI, reading barcodes, stuff like that. And finally, output the result to a PLC or to a robot and have a loop back so that the full system. If we break down this system into pieces, there will be room for potentially AI to help tune the parameters of the system. And I'm foreseeing that as a trend that is happening and will be happening in the future. So AI will not be just used for finding, tuning a specific task and finding a defect or classifying an object, but also tune the whole system as a human would do traditionally with a traditional system. And of course, new algorithms will come. Like, for example, I talked about the few shot and lifelong learning, conditional learning. These are type of algorithm which happen in the academic world and going to the industry pretty soon. And finally, the last thing I would say is that the ease of use is still not perfect. We still need a certain number or level of skill from the end user. We have done a great improvement in that, but there's still room for ease of use to make algorithms even more automatically tuned. For example, auto training with the hyperparameters automatically found by the algorithm itself. That's something it's part of the trends as well.
Yeah. And I guess like a lot of industries, you know, the algorithm is often the king, right? And obviously, you know, incredibly, you know, precious competitively, corporately, commercially, et cetera, et cetera. So I guess, you know, all these things will kind of build iteratively over time. I mean, I'm thinking about, David, in the area that you're kind of focused on. Are there any specific goals that you see AI delivering for what you're trying to do?
Yeah, I mentioned it earlier. I think for me, the big goal is to reduce the cognitive burden on the soldier, and particularly to help them understand the world that's around them so that they can make decisions quicker. And often that really means that they're trying to get around the observe and decision-making loop much quicker than their adversary, because it will give them a tactical advantage. And I think that's obviously an area where artificial intelligence and machine learning can have real benefits to the user. I think specific technologies that I'm targeting, some of them have already been mentioned. So one of those is the use of generative AI for video. So I mentioned earlier that we have challenges in how do we train models and how do we train the people to use the systems. And I think generative AI for video has the opportunity to really enhance that training regime, although we'll obviously have to be careful that we're not training an AI with an AI and going around in circles. So there will still need to be human intervention and human management of the risks associated with that. And then secondly, the near-term technology that I'm targeting is probably more extensive use of multimodal AI. So that really means models that can generate multiple types of data and that can understand multiple types of data, particularly thinking about things like vision language models. So the interpretation of imagery into through a computer system, and then being able to use that to describe the world around it, and maybe, with a much smaller amount of data, be able to convey that as information that intelligence or situational awareness can be gained from. So I think some really exciting technologies there that we would want to apply as soon as possible.
Okay. And Matthias, anything from your kind of roadmap in terms of short to medium term, objectives, or looking further ahead into the longer term?
Yeah, for the moment, the choice of the right topology of the backbone of the neural net itself is still subject to an engineer, an expert, and it would be worthwhile working on optimizing this process so that you're faster in arriving at the final solution for an application, that an algorithm itself generates the best topology for you. And also inference is already okay, but training has to become faster. So it's still time consuming, and you need a lot of data to arrive at the best weights, right? So that's something working on, I think, will come in handy and pay itself off. And also let's say ever deeper topologies that will extract ever more subtle features will help a lot, but along the same lines you need better hardware. But you cannot solve everything by brute force hardware. So you need to invest also in the algorithms itself, I would say.
Yeah. It's
really just taking off.
Sorry, David, go on.
I'm just going to tee off that point. I think that's a really, really good point, that you can't just solve all of this by chucking more transistors at it or more compute power at it. One of the things that I think is a really exciting trend is there a shift towards the smaller, more efficient AI models, and the development and the understanding of how they can be made more efficient, because that really does mean that we can have less compute power, maybe more understanding of how the models are working, but also, I think importantly, be more environmentally friendly in how we train and deploy those models, because they naturally require less power. So that's an excellent point that was made there.
Yeah. And Jan, from your perspective, do customers go in, or people you're working with go in with a view on the impact of some of those issues? I mean, the understanding around the demand on power for data centers, etc., is well understood. But do people go into these sorts of projects with their eyes open, do you think?
I think there's still a lot of education to be done. So, but if you look at where we are with our technology, we're getting quite a lot of success with the let's say the edge-based AI systems, where we have our sensors, our fixed scanners, with a little bit more powerful processors that's able to run those AI models. It's been very successful in let's say for reverse logistics, where we run our deep learning OCR, and also for the anomaly detection. Because at the end of the day, in our world, our customers is looking for a return of investment, and they're looking either for a bigger throughput in their warehouse, or they want to reduce the costs by increasing their quality, or they're looking at speeding up their production lines and increasing their let's say the cost of production. So, and this is something we can't forget, because sometimes if you calculate an ROI, I mean, you cannot spend, at this stage, we cannot spend, let's say, millions and millions in logistics for AI. I mean, they're looking at simple solutions, very easy to deploy, which is going to give them, let's say, maybe a couple of hours per shift of increase.
Just a quick fire kind of question, if I may, to each of you. You're all obviously working for quite distinct organizations with different kind of partners and different types of objectives. AI, I'm sure, has been part of your roadmap for some time, maybe not decades, but certainly, years. Where are you on that journey, in terms of, is this now so kind of front and center to everything you're doing that it's almost the start of the whole kind of debate, or are we still in the early stages where we're just exploring this as a technology opportunity? And Bruno, I'll start with you, if you may.
Okay, we've started this AI initiative about in 2018 by creating a platform for training AI models and providing that to our customers. We are traditionally a component vendors of cameras and frame grabbers. We were looking for a way to provide our customers a higher level of tools to help them solve problems that they have never think of solving in the past with the high robustness of that AI provides. Today, our challenge for the future is we have today a pretty good platform which allows customers to collect images, train AI, and deploy on different platforms. And our goal will be in the future to allow different products from Teledyne to benefit from AI. Right now, we still have some gaps between for example some cameras which doesn't support AI. Edge AI, for example, running the AI in the camera is something we've started, but in the future that's where we're going. And of course, I talked about the ease of use. That's still a high level of effort that we need to invest to make easier tool and still continue to support our customers.
Okay, thank you. David, where's Lockheed Martin in this? Is this kind of front and center now, and has that been the case for a long time?
Yeah, definitely. I mean, Lockheed Martin has always prioritized investment in the platforms and advanced technologies that we're able to access often before other parts of industry. So AI combined with advanced computation and communication resources has been a real focus for the business for quite a long time, particularly as we try to move into what the US military call joint all-domain operations and the UK and NATO call multi-domain operations. Those are rich fields for the application of artificial intelligence and other algorithm-based technologies. I think within the corporation, there's been a significant investment in artificial intelligence, and we've got a number of initiatives and centralized Lockheed Martin AI centers, which then help and support the business units like my business unit sat in the UK with advanced technologies, access to very high-powered computational resources, and people with deep expertise in real niche elements of artificial intelligence. So it really is a focus for us, and aligned to in the UK, well aligned to the UK's defence strategy.
Okay, thank you. And Matthias, what about your organisation?
Yeah, I mean, we're in hyperspectral imaging, right? And for hyperspectral imaging, which delivers high-dimensional data, so we are speaking about more than 250 wavelength bands for every image here, right? It's more of a challenge like using classical machine vision, where you have typically 3 to 5 bands like an RGB camera. So the technology there is not as advanced as in classical machine vision, and the community it comprises is also considerably smaller. So it's in an early stage for hyperspectral imaging, but we are on this journey for a couple of years now and advancing, I would say, rapidly for such a small organization. We recently started with first field tests and so forth, but there's still a lot ahead of us until something like AI becomes also mature for high-dimensional data sets like hyperspectral. Yeah.
Okay, that's fascinating. And Jan, what about from a Zebra perspective? How critical is this as a technology area?
It's very critical. If you see that Zebra has a pedigree in logistics, and if you take machine vision into logistics, AI becomes it's a no-brainer. You can't do a machine vision without it. This is the reason why Zebra has decided to acquire Adaptive Vision, and Adaptive Vision started developing AI 7-8 years ago. So as a result, now we have products that already go to market. As said, we have anomaly detection, we have deep learning OCR, which are being deployed as we speak.
Okay. It is fascinating. It's such a ubiquitous kind of topic that, you know, touches everybody, but it's fascinating and a real privilege to hear so many differing perspectives, but with a central theme, I think, that's reasonably consistent between all of our speakers today. Well, we're coming to the end of the session now. We've been on air for just under an hour. And I just wondered if there was one takeaway piece of advice that you would give our audience about approaching an AI project. Just a quick soundbite from each of you, just as an opportunity to finish the presentation. And in no particular order, I'm going to go back to Matthias again, if you don't mind. You've got a quick takeaway for our audience to think about.
Be curious, be open, but be careful.
Very good. Now, that's exactly the length we're looking for. David, can you beat that one? Thank you.
Probably can't beat the length. It's not just about the technical skills. You do need technical skills, but for me, the soft skills of problem solving, critical thinking, ethical awareness, and also really important in AI, continuous learning are going to be what get you to a solution that meets your needs.
Okay, thank you. Jan, any thoughts, any quick takeaway?
Yes, I think have a holistic approach on using AIs. It's not about only the AI algorithm, the AI hardware. It's about how you're going to implement it. How is this going to look on your production line?
Okay, and Bruno, I'm picking you last. It's the hardest one. Anything to add to those? Very good.
Don't hesitate to consult the expert. I think, like company, we're vendors of product, but we're not just there to sell you product. We can help you in a sustained way to educate you and to help you solve your goals. Like, don't hesitate to consult. Yeah.
Okay, so start talking early. We've got time for one or two questions. Well, one's come in that I'm particularly interested in. Actually, it's probably might be one for Matthias here, and it's about hyperspectral imaging. And the question from Dan is there scope for using synthetically generated data to train models? Matthias, I'm going to go with you, but anybody's welcome to answer afterwards.
Yeah, there is a scope, and you can use generated data for training, but not for really setting up a model, because you will reproduce errors that are in the data set. And if you read in the literature, it's not a good idea actually to use generated data for field applications. So it's only for first tests, but I wouldn't advise it.
Okay. Anybody want to contradict Matthias there, or is everyone happy with this answer? No, I'm getting a nod of assent. Okay, I hope that answers your question, Dan. Well, look, thank you very much to our speakers today, to Bruno, to Matthias, to Jan, and to David. Thank you to everybody that is watching, and thank you to those who don't yet have had chance or haven't yet had chance to watch it. This webcast appears on demand on imveurope.com for up to a year, so tell your colleagues. I hope it's been useful. It's always a real privilege to get 4 terrific speakers coming from very different places. So thank you to all 4 of you for your time today. And thank you to everybody that's watching in. Thanks very much. Hope to see you again soon. Bye-bye.
Thank you. Bye-bye.
Bye.